I'm a consultant neonatologist and I'm a research advocate. And today is the fifth session of series of sessions about research. We started with generating a research question and then reading an article efficiently and timely. And then we tested our hypothesis. And in last sessions, we talked about well, I forget the last session was about, but today we will be about methodology, study design, and or research methodology. So the objectives of this talk is to the objective of this talk is to talk about the component of the methodology, which is the aim of the research, the type of data, type of sampling, time length, and location, how to create the design, what are the steps of writing your study method, what are the research method, how we collect, you design the method to collect your data, and then how you collect the data. And we'll take examples of collecting data. And what are the methods we use to analyze our data? And we'll have some examples. Now, a little bit very complicated topics, but I will try to make it as simple as possible. But this is only one segment of the series. It's a one session, so it will not have all the data because I cannot make it very long. And therefore, I will leave some part of it to other sessions. Like we will not speak a lot about analysis of data. We will leave it to when we do analysis of data, but we will give some hints about it. So let's kick this session with a question, and we'll ask what is the difference between the following research aims. If we are aiming basic or applied, if we are aiming exploratory or explanatory, if we are aiming inductive or deductive. So if you're willing to participate and volunteer the answer, please unmute yourself and help me with that. Any volunteer? If no volunteer, we'll move forward. So the question is, go ahead.
You could answer the second part, could be exploratory, meaning,
yeah.
Meaning no hypothesis, mostly. This is just looking for exploration of the.
So you're just diving in the water. Yeah. You're just going to the research. You're just exploring it. You're just finding the basic knowledge. Okay, explanatory.
Yeah, explanatory. There is hypothesis, and you are looking to. Could be there is the relation, association.
It is the relation. It's the relation between the cause and the result. Explanatory is finding the relation between the cause and the result. Okay.
Yes.
Okay. Any other thoughts?
Yeah.
About basic versus applied, or inductive plus deductive? Now, inductive plus deductive, think it in this way. When you do a scenario or resuscitations or a procedure, before the procedure, you do briefing. And after the procedure, you do debriefing. So same, inductive plus deductive, you can think it's not the same, but it's in the same way of thinking. So let's move forward and see how we can talk about. So if you look to this table, it gives you the difference between basic versus applied research type, exploratory versus explanatory, and inductive versus deductive. Now, how you differentiate? First, we look to the aim difference. In the basic, you are looking for developing the knowledge, having the knowledge, starting the theory, prediction of the theory. While applied, you apply the technique to have a product from the knowledge, or you do a procedure. So the basic knowledge is to consider is when you expand your knowledge. You don't have an idea, but you want to build an idea. While in the applied, you want to solve a problem. You know the idea, but you need to solve the problem. The exploratory versus explanatory. The exploratory is to explore the main aspect of the problem, to know the unknown, while explanatory is to explain the relation between the cause and the result. And the explanatory you should have a very well-known idea, while explanatory, you don't know the idea, it's unknown. In the explanatory, you know the idea. So the explanatory is to give you how much known about the problem. It is the initial part of the research to find the problem, while the explanatory is to seek the precise conclusions and to establish a connection between a cause and result. Inductive versus deductive. Inductive is to develop the theory, while deductive is to test the theory. So inductive, you don't have any idea, you don't have a theory, you have to build it. While deductive, you have the theory, but you're testing it. Any question? You guys understand? So when you start to write your methodology, you need to state the aim of your study. And depending on type of the study, the type of problem, is a start or already known? Are you finding a theory or explaining the theory? You need to write the methodology, and in the methodology, you need to write the aim. So do you have any question about the aim? Because it's not easy to digest. Any question in that area? Okay, well, let's go to another question. What is the difference between following data type? Primary versus secondary, qualitative versus quantitative, descriptive versus experimental. Anybody want to answer any of these questions? Yeah, go ahead. Well, I'm very, very thankful for your interaction.
Primary, the main aim of the research, primary.
No, this is data. This is not aim. This is data, data type.
Okay.
Yeah, data type.
Okay.
Any other people? Any thoughts? Any thoughts?
Hello.
Yes, ma'am. Go ahead.
Can you explain aim again? I did not get it in the clear picture.
You did not get it. Let's go back to the aim. So the aim of the study is what's your intention? Why you're doing the study? So either you are exploring an area, okay, or you're finding the relation between the cause and the result, or you are finding the explanation of the process. So basic, you have no idea about a problem. You just go and search it.
Okay.
You're seeing a problem, you don't know anything. While applied, you know the problem, okay? You know the problem, but you want to apply a technique or a procedure to explain it.
Okay.
So the basic is you building your knowledge. The applied is you're solving the problem. You know the problem, but you want to solve it. You know, find the cause, you know, find the diagnostic, you want to find the treatment, and so on.
Okay.
Exploratory, okay, you're going to area that you don't know, so you're exploring it. You're doing something to explore the unknown. Explanatory, you know it, but you want to find a theory, a well-defined, structured theory to explore, to analyze this problem. So if there is much known about the problem, you go explanatory aim. If this problem has no known anything, then you go for exploratory aim. Inductive is before you start, you need to build something. Okay, so if you have no house, You need to build a house. So that's inductive. If you want to test if your house is good, then that's a deductive. Well, if you want to answer the question, Rasha, you need to answer it by voice so others will help it. Texting it is not something else. So inductive is you want to build the problem, want to build the test, while deductive is you want to explain it. So now we go to the data. We have a primary data, we have secondary data, we have a qualitative data, and we have a quantitative data. We have a descriptive data, we have experimental data. Now, why when we're writing the method, we need to write our aim, and then to write our design, the study design, you need to know your data types. And when you have your design and data type, you can build your test, your analytic test. So one is connected to other. So let's go to explore what is the primary and secondary data. Primary data is the data collected by you. You do interview, you do experiment, you do observation. It's the data collected by you. While secondary data is the data that is not collected by you. It's collected by a government or an organization or previous publications. So you go and use it. So to decide is it primary or secondary, you need to know how much known, how much data available in that area. If the data is available, like the age of people, and there is consensus from the government, then you don't need to go and ask yourself, you just use it. While if there is no data, like for example, the prevalence of COVID-19 infection, you need to do it yourself because there is no data. So primary or secondary depend on the availability of the current data. Qualitative versus quantitative. Qualitative search focus about the meaning, the understanding, the emotion, the status, okay? While the quantitative is numbers. So qualitative, what you consider it when you want to measure or interpret an emotional status, an opinion of somebody. While quantitative data is to find the relation between a cause and the result by numbers. However, sometimes you can combine both qualitative and quantitative. So quantitative, you can test by test analysis, or while the qualitative, you cannot. Descriptive versus experimental. Descriptive, there is dependent and independent variables, if you guys remember from previous session. And descriptive, you do not interfere. The independent variable causes the dependent variable. You just go and look at it. You have smoking causing lung cancer. You go under. While if you wanted to be experimental, you expose some to smoking and you don't expose other to smoking. So you interfere with the independent that can cause or change the dependent. So descriptive, you go and describe. Experimental, you test yourself. Experimental, of course, can be in the lab, can be in the field. So if you want to describe the characteristics or the pattern or the correlation, you go descriptive. While if you want to find a cause and test that cause, is it significant or not, then you go for experimental. Any question about type of data? So we talked now about aim of the study and now type of the data. Any questions so far? Because I really want you to understand before move and things become more complicated. Any questions? Go ahead.
The secondary, which you explained, that secondary data which we cannot do, that primary we can collect, and secondary data I have to get from some source like any institute. So where we can apply this?
So if the data is already available, then you select the secondary data. For example, you have like 10 study about problem A. So what do? You don't go and do another study. You go and do a meta-analysis or systemic review because the data already available. You don't need to go and do it yourself. While if that problem have only one study, then you go and do primary data. You do the data yourself.
So I don't need to collect in that case. So I will get that and I will analyze that.
Yes, exactly. So secondary depend on the problem. Is the data available or not? Okay. For example, you know the government do consensus every year or every 10 years. So you don't need to go, you do consensus yourself because that's lots of resources. But if the data available, you go and take it from the resources. And there are many resources organizations, can be governmental and non-governmental.
Okay, thank you.
The qualitative is you cannot test. Quantitative, you can test. You can do test analysis. Quantitative is number. Qualitative is a status, is an emotion, is a perception. Descriptive is you don't interfere. Experimental, you interfere with the data. You expose some of your subject to it.
Experimental, like in preterm babies, we do the experimental. It can be like that.
No, experimental can be anything.
Anything, okay.
Anything can be experimental. When you interfere with the independent, affecting or causing the dependent, this is experimental. Okay, like let's say you have two types. You have seminar and lecture. Okay, so if you do random selection of your student and put them to these two arms, that's experimental. While if you have the lecture versus already implemented and you go and describe it, you don't interfere with it, then that's a descriptive. So anything can be descriptive or experimental. It depends. If you want to just find the pattern and the correlation, you do descriptive. But if you want to test the cause and relation, then you do experimental.
Experimental, yes, okay.
So we've talked about type of aim of the data or aim of the study and type of data. Any questions so far? Okay, let's move to the next.
Yes.
What is the difference between research type? We have a probability versus non-probability. There is two people are raising question. You can answer, like you can ask a question, whoever raising their hands. Any question? You can unmute yourself and ask.
Assalamu alaikum. The difference between the objective and the aim of the study.
The aim of the study is what you are looking for. Okay, I'm going to go back and repeat it, but not now. But the aim of the study, what you are looking for. Are you looking for basic? You have no idea about the research, you want to build an idea? Or no, the idea is still there, but you need to see if there is a risk causing this problem, or you can manage the, or treat that problem. So you do apply. So basic, you search the idea, search the problem because you don't know, apply. And then you have exploratory versus explanatory. So exploratory, you don't know the problem, you have not aware, it's all unknown, you go and dive in that sea to see what is the result, what you will find, fish or whatever. Explanatory, no, you know there is fish and there is sharks, and then you know to see the effect of these fish and shark on, for example, beach attendants. That's exploratory versus explanatory. And then you have deductive versus inductive versus deductive. And it's the same. Inductive is to build the theory. Deductive is to test the theory. So if you have already the theories there and you want to test it, then you do the deductive. Okay? So now what is the type of the research? Probability versus non-probability, which we talked about a little bit in the last session. Cross-sectional versus longitudinal study. Field versus laboratory study. Fixed versus flexible study? Any idea? Anyone want to answer?
We talked last lecture about this probability and non-probability sampling. Probability we have يعني about 4 types of probability: random sampling probability, systematic probability, striated sampling, or
Yes. So what is the difference between probability and non-probability? You know, that's the type.
Non-probability and the probability. As you said, Dr. Yahya, every element have equally chance to be selected.
Yes.
Yes.
And so the probability is you, in short, the probability you can test. Non-probability you cannot test. Okay, that's the difference. So probability you do randomization. Non-probability there is no randomization. Probability each subject in the population have the chance to be selected. Probability each selected subject will not affect the selection of others. Non-probability, no, not any person, because you're not doing random. Not every subject in the sample are, and therefore you cannot test. So probability study, you can test, you can do a statistical test. Non-probability you can. Probability there is randomization, non-probability there. We'll talk about it. What about cross-sectional versus longitudinal study?
Cross-sectional study, a snapshot, you are taking a sample within one time.
The time scale is the difference here. Yes, you're right. What about the field versus, it's clear. The field is you go outside, laboratory, you create the environment. What about fixed versus flexible? Okay, well, let's go and talk about it. Okay, so here's the explanation. Probability versus non-probability sampling. Probability is you can test, and therefore you can infer, or you can generalize, or you can relate the finding to the population. So because you're doing sampling, and that sampling is random and representing the targeted population, then you can infer it. While non-probability, you just draw conclusion on that people, on that subject, on that sample. You cannot generalize it. Okay, and the reason because you are not randomizing it. So if you want to generalize your conclusion on a large scale, on a large population, you need to do probability. If you want to just know the details of this of the problem, then you do non-probability. Cross-sectional versus longitudinal. Cross-sectional is one time snapshot. You go and do it. While longitudinal is over a long period of time. That's why they call it cohort, because you're cohorting it, the data or one. It can be prospective and it can be retrospective. So if you want to understand the current situation, you go cross-sectional. If you want to track the changes over time, you go for longitudinal. The field is you go for nature, you go for real world, you don't change it. It can be in the lab, of course, but you don't change. Laboratory, you change the environment. You change the independent to cause changes in the dependent variable. So if you want to find something in real world, you do field study. If you want to find something or find the relation, if you want to find the relation, alaykum assalam wa rahmatullah. If you want to find the relation or draw conclusion, you go for laboratory study. If fixed versus flexible, fixed is you do the design prior to the recruitment and you never change it. Flexible, you change it with time. So if you want to test a hypothesis, you have to go with fixed study. If you want to generalize your conclusion to a large sample size or targeted population, you do fixed. But if you want to do not make generalization, you do with flexible. And why use flexible? Sometimes you don't know the incidence. You cannot do the sample size. You don't know the prevalence. So you go with the flexible because you want to build the prevalence. So The type of sampling or type of time scale and location are these. So we need to mention is it probability or non-probability? Is one time or long time from that period to that period when you write? So I'm doing a prospective study over 3 years from 2016 to, or I'm doing retrospective, something like that. And then where is the study? Is in the hospital? Are you doing laboratory? I mean, you're changing the independent or so on, and then fixed or flexible depending on your data. So the other question is not the research type, the data or the data representation type. This is typing error. What is the difference between mean, median, and mode? Any idea? Okay, let's give the floor to the lady. Yes, go ahead. Who is this?
Assalamu alaikum.
Alaikum salam.
Banozat from Iraq.
Yeah, go ahead.
The first one mean the value when summation of the values. Which
so it is the average. It's the average of the data.
Yes.
Okay, median.
Yes, this mean median mean the value in the median of the values.
In the middle. You mean in the middle? The median is the middle value.
When the values get in a range.
So yes? You put the values in a range from the smallest to the largest, or from largest to the smallest, and then you select the middle one. That's the median, correct?
Yes.
And the mode?
The mode, I can't remember exactly, but what I need.
I can tell you. I remember. I can tell you. It is the most frequent values.
Yes.
Okay. Yes. So let's give an example. If we have 11, 11, 10, 10,
yes,
and 9, 9, 9. So what is the mode here? Is 9. What is the median? Is 10. The mean is you submit all and you divide it by the number, you get the mean. Okay. So what is normal distribution?
The normal distribution, if we have a curve.
Yeah.
I remember like only.
It is a bell-shaped curve.
Bell-shaped. Yeah, bell-shaped.
It's a bell-shaped curve.
The right side equal to the left side.
Whereas the median, mode, and mean are the same.
Yeah.
So if the mean, median, and mode are the same, it's called normal distribution. If the median is bigger than the mean, it's called positive skewed. If the median less than the mean, it's called negative skewed. Now let's do graphics and understand it. So this is, you can see here, this is a normal distribution curve. Where is the median, the mode, and the mean are the same. And on both sides, there is standard deviations. There is a variance of difference. There is the range between the two arms. When it's become positive skewed, you see the mean is bigger than the median. Okay, because you have more values on one side. So this is normal distribution. It's symmetrical distribution. Positive skewed, the mean is bigger than the median. And negative skewed, the mean is less than the median. Okay, so you need to mention you need to mention that in your study. So if you're doing applied, not basic research, now you have already the theory and you want to test it, you need to know the distribution of your data. Okay, because when it's skewed, you cannot apply standard deviation. You need to apply another type of test or another type of analysis. So to apply a standard deviation or a variance of difference, or the range, you need to have normal distribution where the mean, median, and mode are equal. But if it's skewed in positive way or in negative way, you need another data or another statistical test. Now, how you know that? You don't need to memorize it. You just need to tell the software that this data is skewed. And the software, and then when you give the data, the type of the study, the aim of the study, and so on, and the type, and the system will suggest for you the test analysis. Okay, now how to create a research design? You need to do a framework. How you do a framework? By answering the questions that we've said it here. What is the aim of the study? What is the type of the data? And what is the time scale, location, and sampling type? And whether your data is primary or secondary, qualitative or quantitative, descriptive or experimental. So you need to to answer these questions and put a framework. So you say the type of your data, the location and time scale, the participant, the sampling, the source is primary or secondary. And then you mention your variables, dependent and independent, and you make your hypothesis. You have all to mention that. So you make a framework of exactly, and after you make the framework, you start to write the methodology. You need to include how you will collect your data, and then how you will analyze your data. Now, the analysis of data depending on the design of the study, the data type, and so on. And then you need to determine what exactly the parameters that you want to include in your study. You need to mention exactly the criteria that you will be using to evaluate the result. And then you need to mention, is your result reliable or not? Is there a limitation to your study? And then you need to validate internally in your hospital and validate it externally. Can we get the same result if we apply that in another institute? So, and this depends on how you collect, how you measure, how you analyze, how you interpret your data to make sure it's reliable and valid. The strong research design is crucial for a respectable, successful research proposal. Now, remember that when you write a study, the facts are not enough. There is something called priorities and practicalities. So you have your aim of the study, you have the type of the data, you have the type of study, you have the time scale, the location and sampling, you made your conclusions, you determine the reliability and the validity. But again, is that possible? And if it's not possible, which one is not possible? Which one is possible? And if more than one thing is possible, what are your priorities? So priorities and practicalities are important in writing study design. So priorities and practicality applied on the type of data, how to collect the data, how you analyze the data, and when you write your research proposal. Now, the research proposal are important in two areas, or three areas. First is to get REP approval, Research Ethics Board. Second, if you want to apply for a grant for money. And third, to convince your colleagues or other center to be in your study. So writing a research proposal does not depend on the facts. It depends on priorities and practicalities. For example, doing a study in a country is different from doing study in another country because the state law is different. The mentality of the people are different. The ability to get consent are different. The resources are different. The easiest or the hardest way to collect the data are different. So priorities and practicalities are important on all the aspects of the methodology that we spoke about. Now, I don't want to go to these details because I already spoke about it, but remember, a quantitative case study is good for gaining in-depth understanding of specific context, but it does not allow you to generalize a wider population. So the priorities and practicalities is gaining in depth of understanding is important to you or not. If it's important, you go ahead. If it's not important, then don't. Another example, a laboratory experiment allows you to investigate the cause and effect, find the relation between the dependent and independent variable. You can do internal validity, but laboratory study cannot do external validity. You cannot generalize it on real world. So if you want to generalize a conclusion on real world, don't do a laboratory study. You need a field study. So again, priorities and practicalities are important in writing the methodology. Okay, I think I have somebody is asking. The difference between field, I have a question from Dr. Abdullah. The field study is you go outside, you go to the hospital, you go to the institute, you go to the street and study. You can do both descriptive or experimental in both laboratory and field. In laboratory, you create the environment, you create the risk and assign it if you want to do probability, or do not assign it if you don't do non-probability study. While in the field, you cannot create it, it's there. But what you do, you can assign people of a risk that's already there to this or this arm. So the field, you do not create the environment. While the laboratory, you create the environment. Both of them can be experimental or can be descriptive, can be analytic, can be descriptive. Now, when you do your priorities and practicalities is you consider your time. For example, if you are a fellow and you have 1 year, you cannot do a study that needs 3 years. Also, the ability to collect the data. Do you need to travel from a certain location? Do you need to contact specific people? Do you have resources? Do you have the necessary skills? So if you don't have a statistical analysis skills, and you don't have with you a statistician, although I don't like the statistician doing the study, I think you should learn it because a statistician is very good, but he will not understand the study in a specific area like the person who has the expertise. So do you have a statistical analysis skills? Then do probability. If you don't, then don't do it. Do non-probability. Do you have interview skills? Then go and do interview research. So define your question, refine your question, change your question according to the practicalities and according to your priorities. Now, it's very important to determine the data, and I'm going to speak about the data type, whether it's primary or secondary, qualitative or quantitative. We already mentioned that, but we'll talk about a little bit more details. Primary, you collect the original data. Secondary, you analyze already existing data. Primary, make your research more original. Secondary, save your time. Primary data are limited. Secondary data, more generalized, have wider scope. Primary data, you have control over the independent variable to change the dependent. The secondary data, you don't have that control because it's already there. Qualitative data. Qualitative is descriptive of a status or emotion or a face it interprets the meaning of thing. It talks about concept. While quantitative is numbers, it's a measurable variables. Quantitative is not measurable. In qualitative, you can find the frequencies like average, mean, percentile, and then you can find the correlation between, and you can do test hypothesis. In qualitative, you cannot do that. You cannot do frequency and correlation tables, but you can understand the concept. Qualitative is very flexible because you can change. Quantitative is fixed, it's numbers, you cannot change. In quantitative, you have to determine your variables before start collecting the data. While in quantitative, you can change it with time because you're talking about emotion. So with the research process, because you're not testing it. Now, when you talk about primary and secondary data, somebody is raising your hand, so you can go ahead and ask question if you want. Who's raising the hand? Anybody? Aliyah? Dr. Aliyah? You're raising your hand. Do you have a question? Anybody? No question. Okay, maybe by mistake. So when you consider your quantitative or qualitative data, again, consider your priorities and practicalities when you do. You can combine both of them. You can combine primary and secondary data.
Sorry, Dr. Yahya. I
Yes.
am raising hand. Excuse me, I want example for qualitative data.
Okay, so qualitative data, let's assume you are a neonatologist and you're working in a very busy NICU, and you want to see the effect or scale the emotion of the parent when you break bad news to them. That is a qualitative study. Quantitative study, you want to test how many parents turn aggressive when you break bad news. So here you write numbers, while there you don't write, you just assess. And I give you another example. You want to test the feeling about the people who are doing elective surgery on the morning of that day. Are they happy, sad, excited, and relation with that, with the gender, with age. While in quantitative, you want to say how many people are depressed on the same day of surgery. So this is qualitative, this is quantitative. So quantitative are numbers that you can test. Qualitative, you cannot test. Qualitative, you can change with time. Quantitative one, we cannot change. Quantitative is you have to determine it before the study. Qualitative, you can change with going on when you go on and collect the data.
Yes, thank you.
You're most welcome. So now, please remember to consider your priorities and practicalities when you consider qualitative or quantitative. Now, the collection method also changed. It can be survey. So you send something to these surveyors and they answer. And usually, remember, the survey is a non-probability study. It's a simple randomization or stratified randomization or cluster randomization or systemic randomization or because it's non-probability. While interview is depend, so the main issues of the survey is how to get the response of people and how to send the surveyors, how to reach them, by person, post, online. So the most important part of a survey is how to design the questionnaire and how to reach the respondent. While the interview is how to select the participant is the important. And where to take the interview. And is the interview structured? That means it's written and then you tick, or it's semi-structured. You have a question. If the answer is yes, you tick. If the answer is no, you write notes. or it's unstructured. You go on interview and take the information as it goes. So in the interview is the most important: how, where, who, and how. In the experiment, then you have to decide, are you doing it in the laboratory to create the environment, or are you going outside in the field? And the experiment is important to know your variables, the dependent and the independent, and how to measure them, and how to control them, and how to avoid the confounders. The independent that you can change. If you change, then this is experimental. If you cannot change, then this is not experimental. So then most important in experimental is the design environment, how you design the environment. And what is the relation between subject or within the subject, how to do the randomization, how to blind people when you do experimental study. The most important is blinding, because we used to call it double blind, or first single blind and then double blind, and now they call it all level blinding. The other method is using secondary data. And imagine, or an example of secondary data is meta-analysis and systemic review. I want to answer a question. Anybody knows the difference between meta-analysis and systemic review? Any answers? Any volunteers? The difference? We hear meta-analysis, systemic review, and meta-analysis. Any volunteer to answer the question? Yeah, go ahead.
Yes, I am Dr. Rami. Meta-analysis, my inclusion criteria is the result of many studies. Systemic review, my inclusion criteria is the whole studies from many populations or many countries.
Yes, you understand it, but let me put it in a better, not a better, but a more simple frame for people. In meta-analysis, you take the raw materials of previous studies and then you test it yourself. So again, in meta-analysis, you take the raw materials, the raw data of different studies, combine it, and do the analysis yourself, like when you do Cochrane review. Systemic review is you compare the result of various studies. Systemic review, if you compare the result, you don't take the raw materials. That's the difference. So both of these studies are secondary data. Then you have to decide how to analyze your data. To answer your research question, you will have to analyze your data and then depend on many things, how to analyze it. Is it descriptive? So you do frequency, mean, medium, range, or it's analytic. Is it qualitative or it's a quantitative? I have a question, or probably more than one question. Thank you very much. Aliyah was not raising her hand. That's okay. Thank you very much. So to answer your question, it depends on the aim of the study, the type of the data, and the study or the method of the data, and how you collect and whether it's resonant. And then you do the test. How you do, you enter all this in a software, and the software will tell you what exactly the test you need. I'm going to give you an example of these tests, but I don't recommend, or even I'm not expecting that you will memorize it. So when we do qualitative data analysis, quantitative, sorry. So to analyze the numerical data, you probably need a statistical method. So we can use an Excel or SPSS or SAS. And the statistical method can be used to analyze the average, the frequency, the pattern, the correlation between these variables. And remember, the variables are two types: dependent and independent. Always remember that. And when you create your research design, you should clearly define your variables, formulate your hypothesis, the relation between them, so it's easier for you to test it when you have your numbers. Because the selection of the test depends on the hypothesis and the type of your variables. Qualitative data, it's a word, it's an images, it's more flexible process. Okay, its main focus on categories, on key themes, or interpreting pattern, or it's a narrative. So you just You just transferring the information. It's understanding the social context, the meaning. Okay, so the main, sometime in the qualitative data, things are emerged after you start the data. While in the quantitative, you never do that. Everything should be said before you start collecting the data. So in qualitative is mainly descriptive. You cannot apply tests. So people are waiting. Let's admit all of them. Okay. So in qualitative, it's focused on what is happening and who did that. There is no analysis. So the research design is very important. If you're doing dissertation, thesis, proposal, getting ethics board approval, it describes exactly what is the plan that you want to do and how you plan to do it. It should show both the practicality, feasibility, and capable of answering your research question. To write the protocol, you need to attend our next session on writing a research protocol. In a proposal, the steps of your research should be in future tenses. While the research design and the methodology, it should be based on past tenses. So the research method should describe how to collect the data, how to analyze it. We have more people waiting. Okay, and again, you have to describe whether it's a qualitative or a quantitative, primary or secondary, descriptive, experimental, and then decide how to analyze the data. Is it quantitative? You will use statistical analysis. Is it qualitative? It's more thematic analysis, it's more interpreting the pattern, is more talking about the meaning of the data. And then you have to mention how you collect your data to answer the questions. And the collection of data depends, is it quantitative or qualitative data? Then you have to develop a collection sheet. A collection sheet can be soft copy, it can be hard copy. So it can be, for example, Excel or Access, or it can be hard copy. Once you collect that data collection sheet for each subject, you need to transfer data to a master table to do the test and analysis, to write the graphs and so on. So method of collecting data, again, it depends on, is it qualitative or quantitative? And here I'm talking about the pros and cons of each one. So I'm not gonna go to, because the quantitative is easier, it's more systematic. Qualitative is a little bit flexible, it's a little bit vague and so on. Again, is it primary or secondary data? Primary need effort, it's a limited data, you need to develop your own, you need resources and so on. While secondary data, it's already there, you can go and collect it. So if it's a novel idea, you need to do primary data collection. If it's, you want to talk about existing knowledge, then you need to analyze, and you need to analyze the trend or identify a pattern, then use a secondary data. And here's the pros of cons of collecting primary versus secondary data. Secondary is easier and faster. This is more difficult. This can be big sample. This is a small sample and so on. And then is it descriptive or experimental data collection? So you're just describing water, or you are interfering? Are you looking to see the relation between the result and the cause and the result as it's there in the environment, or you want to create a cause or a reason to find the result? So you need to make sure, and then there's, each one has validation and each one has a study design that need to be determined. Now, sometime you have to do descriptive because it's not practical or it's not ethically possible. And here is the difference of collecting descriptive versus experimental data. So these are the cons and pros of each one of them. When you collect the data, the survey, now I'm giving you an example, a combination of examples. So imagine it's experimental study, then the data will be primary. Is it qualitative or quantitative? It's quantitative. And what to do with experimental? You're testing the cause and the effect relation. Survey, is it primary data? Yes, because you're doing it yourself. Is it quantitative? Yes, because you are getting numbers. And it's what to tell you, it gives you the general characteristics of a population. What about interview or focus group? Can you mute yourself? Okay. So interview or focus group, is it primary? Yes, but it's qualitative. It's more gain depth of understanding of a problem. Observational, is it primary? Yes. Is it qualitative or quantitative? It can be both. Literature review, is it primary or secondary? It's secondary. Is it qualitative or quantitative? It can be both. And it works on the existing research, on existing data. Case study, is it primary or secondary? Yes, you can do your own study, primary, but also you can take studies from other people. So it can be either. It's qualitative or quantitative, it can be either. It can be gain in depth. Case study usually in rare diseases or case or problem. So now we'll go to the method of analyzing the data. And again, we've talked about many times, depend on the, is it qualitative or quantitative, it's primary or secondary, and so on. So in a qualitative analysis, there is no test. So either you ask open-ended survey and using non-probability sampling method to analyze your data when you do qualitative analysis. So for the open-ended survey and interview or literature review, case study, other sources are all qualitative. And remember, it's non-probability. You cannot do a testing on it. And it's flexible because it changes with time. And relies on the research judgment because it's qualitative, not quantitative. So because it has lots of choices and assumptions. So remember, when you do analysis of qualitative, these are your areas to look at. When you do quantitative, it's numbers, so you can do tests. You can know the frequency, the average, the correlation. You can study the cause and effect relation. And you can interpret the data either during doing experiment by exposing some to and none to others. And you can do probability sampling, and then you can do hypothesis and test the hypothesis. And because it's, remember, it's a quantitative, you can generalize it. And you can share it with other people, with other organizations, because you can generalize it, because you're testing it. So here's example of data analysis. So statistical analysis are quantitative. Meta-analysis is quantitative, while systemic review is qualitative. So remember, meta-analysis is quantitative because you're taking the raw material. Thematic analysis is qualitative because you're just describing you're collecting data from interview or focus group or textual resources. The content analysis can be content analysis example, systemic review can be either quantitative or qualitative. So what are the tests that we use for probability or for qualitative tests? There are many. You can see these are examples of some. We have this test called one sample t-test, one sample median test, binomial test, chi-square, I think some of you heard about. Chi-square goodness of fitness test, two independent sample t-test or student test, Wilcoxon, Mann, Whitney test, and so on, chi-square test, Fisher test, ANOVA. analysis of variance, and so on. So you can see there are different tests that we can use in probability testing, and it's used on the quantitative, and the selection of the type depend on your type of the data and the type of the study and the aim of the study. Is it categorical or it's a continuous? Is it dichotomous or it's ordinal, and so on? And how you know that? You don't need to know that. You just put your data and the system will tell you what is the test best for you. Other simple logistic regression, multiple rejection, analysis of covariance, and so on. These are many types. I'm gonna give you an example, but I don't realize, or I don't expect that you will remember it. The most important is you remember your type of data, you enter your data into the system, and the system or the software, like any statistical software, will tell you exactly what type of the test, but you need to know how to interpret the test. So here's an example. I'm giving you how to analyze a test. I'm going to give you one of the examples. So one sample t-test allow us to test whether a sample mean of a normally distributed interval variable. So it's interval variable, it's a continuous, it's a normal distribution, and we're talking about the mean. So we have two means, the mean of the actual and the mean that we hypothesize. Are they different? So you can see the writing score, the t-test value. Here is the degree of freedom, which is equal the number minus 1. So the total number of the sample is 200, minus 1 is 199. The significance level, is it 2 tail or 1 tail? The mean difference, and then the confidence interval. The confidence interval is how confident you are that this test, the mean, is actually equal, the hypothesis mean is equal to the actual mean. So I will be 95% confident if the value of the hypothesized mean is between 1.4 to 4. So I will be 95% confident that this range of the hypothesized mean is equal to actual mean. That's what we call it, confidence interval. How confident you are between this and that value. And you can see, you can have the mean, and then you have the standard deviation. And the reason you have standard deviation here, because it's a normal distribution. So this system, when you say and you give all these numbers to the system will tell you. More examples. One median test. I'm not going to speak about it. I'm going to skip it. But you can, if you are interested and read about it, you can stop the video later on and look at it. But I don't want to go because we will have a session about statistical analysis. Binomial test, again, each one. So you can see the one sample binomial test allow us to test whether a proportion of success on two-level categorical dependent variable. So it's categorical variable, it's dependent, and significantly different from hypothesis. So we're not talking about the mean here, we are talking about the actual values. Okay, and it's two-level, so two numbers. So we do binomial tests. When you give the feedback, the system by this, it will tell you what test you need to do, but you need to know how to interpret. Chi-square test, again, I'm not going to speak about it. Two independent sample t-test, and go Wilcoxon, Mann-Whitney test, and so on. There are many tests. It's mentioned all here. ANOVA test. ANOVA is when you have more than two relation analysis. So whenever you have more than two variants, independent variables, and then you want to analyze it, especially if it's categorical, so two or more, you do ANOVA, or analysis of variance, because there is A, B, and C. A might affect B, B and affect C. So what ANOVA does, fix A and then test it with B, and then fix A and test it with C, and then fix B and test it with C, and fix B and test it with A, and then fix C and test it with B, and fix C and test it with A, and so on. So that's called ANOVA, analysis of variance. And there are different types of ANOVA. This is factorial ANOVA. Friedman test, order logistic regression. Okay. the logistic regression usually tests the dependent variable, not the independent variable, and logistic regression or the regression in general should be a continuous variable, sorry, ordered variable. Factorial logistic regression, when you have two or more categorical independent variable. Correlation, it's relate the two or more categorical independent variable, but they are dichotomous, and so on. So I'm not really want you to know this now. We will do that more when we do statistical tests. But today we are just talking about the how to write the design, and part of the design or the methodology is to write the test. Spearman correlation. There is parametric when the variables are normally distributed, and it's non-parametric when they are skewed, and so on. Simple, logistic, regressive, and there are many. I'm going to pass all of them. Okay, and I think I am done today, and I'm happy to receive questions if you guys have any question. I know it's a little bit tough topic today, but I hope you do not concentrate on statistical test for today. You just concentrate on how you write your methodology, and part of it is a statistical test, and you will understand the statistical test and their type when we do the statistical test types. Okay, I have questions. Let's see. Could you please give an example on how qualitative data might change with time? Okay, well, easy, Manal, Dr. Manal. For example, if you wanna test the emotion of people about a problem, and so you wanna assess their emotion, and then you want to categorize it to a degrees. But when you do that, after 1 or 2 days, you find your category is not enough. You need probably to expand it. You find a new emotion. You find a new interaction. Okay? Or you want to get an opinion of people about something. And you put in a conclusion that opinion of people in Japan, for example, is this and that. But when you start to do study, you discover they have different opinions, so you need to change. How to write a review articles? How to write a review articles? Writing a review articles, you need a practice. It's not different from any article, but you need a practice. So you need to write your abstract, your introduction, what is known and what is unknown, and then it depends on your specialty. You and depend on the journal and the preference and the style, you write the sections of that articles, and then you need to reference it. Now, once you reference it, you need to write it in your way, which means you don't copy and paste. Writing a review articles, you need a 1 session alone. Dr. Hazem is asking, can the study be a descriptive cross-sectional? Yes, of course. Yeah, it can be descriptive and cross-sectional. Descriptive is mean you're not interfering. Cross-sectional mean one time. So yeah, it can be descriptive one time. What is the difference between deductive and inductive? The difference is deductive is building the idea. Inductive is testing the idea. Deductive is you have no knowledge about the problem. Inductive, you know the knowledge, but you need to test the cause and the relation. The question is that about retrospective and prospective. Both of them are cohort, both of them are longitudinal study. The prospective is you monitor. So while retrospective is people recall the finding. So prospective is you start before the risk caused the disease. Retrospective is you start when the disease already happened and you go back to find the risk.
Hello, Dr. Yahya.
Sample size calculation. I'm going to answer the question and answer. What is the standard we meant and how to get in the example? So the standard deviation, it tells you the range, the variance of difference, how your variables are distributed away from the median of the mean. So how stretchable are your data? And it depends whether it's one tail or two tails, and it's one or two standard deviation used, you go and take it from table. So you said one tail, and then the standard deviation is equal to that number. So, and there is a table to give you the numbers that you need to use. Any more questions?
Hello, Dr. Here. Hello.
Hi, go ahead. So I'm going to answer a question before. I have a question. What is the degree of freedom? Is the degree of freedom is the total number minus 1. So it tells you whether the test affect the sample when the subject is selected. So if you have 200, if we remove 1, does that removal of 1 will affect the result? That's called degree of freedom. It's the number of the sample minus 1. Yes, sir, go ahead. You want to ask a question?
Hello, I am Dr. Dilip. Hello.
Yeah, go ahead.
Can you hear me? Okay.
Yeah, I do.
I have got two questions.
Go ahead.
First is regarding the qualitative data, because I understand that majority of the studies which we do are quantitative studies, isn't it?
Yes.
So qualitative studies.
Not majority, not majority. Now there are many studies are qualitative actually.
Okay.
I'm done very many qualitative studies. Okay, go ahead.
Okay, so qualitative studies, I didn't understand it fully, but what I understood from what you explained in this session was it just basically measures the behavior of people in the example which you
behavior or status or perception or emotion or understanding or thoughts or opinions are all qualitative.
Okay.
Anything you cannot measure, anything you can assume. Yeah, go ahead.
Okay, so in the example which you gave regarding the aggressiveness of the people after you break a bad news to the parents.
Not the aggressiveness, the degree of aggressiveness.
Oh,
that's a qualitative, but aggressiveness is quantitative.
Okay, so suppose if there are if you study 100 cases, and out of that 100, if you get 50 people who are aggressive.
No, this is a quantitative. Once you say numbers, it's a quantitative, not qualitative.
Then how will you express the qualitative data? So
qualitative is when you express a bad news. What are their feeling? How you assess their feeling? How you assess their reaction? So let's say I would say when I break bad news to people of CTA, their behavior mostly empathic.
Okay.
While when I say qualitative, I would say 50% of people in CTA are actually apathic. So this is a quantitative. The first one was qualitative.
Okay. So 50%, if you mention that
if you say number, it's a qualitative. Remember that. Go ahead.
Okay. 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 So the second question is, do we have standard deviation for any positive or negative skewed data, or is it standard deviations are meant to be mentioned only for those data who, which is
standard deviation mainly for the normal distribution.
Okay.
The skewed data you use non-parametric tests.
Oh, okay.
There are specific tests for skewed data. There are specific tests for skewed data, and if you say it's a skewed, it's positive skewed in your, the system will tell you exactly. If you have the, for example, SPSS program, if you say it's skewed positive, it will tell you exactly what test you need, and then you have to mention: is it like a continuous or categorical, is dichotomous, is binomial, is it relational, is continuum. So you have to mention to the system what is it exactly, and then the system will tell you what is the test, what is the suggestive statistical test.
Okay, so basically standard deviation is used or mentioned or
for normal distribution,
for normally distributed data.
It can be for none, but I don't want to talk about it. It's too complicated. But remember, standard deviation for normal distribution. Now, I have a question about one-tail or two-tail test. Now, if you have an intervention and you don't mention the effect, whether it's on the positive or it's on the negative, then this is one-tail. Okay. If you mention the direction of the effect when you implement an intervention A, the intervention can be positive and it can be negative, then that's two-tail. So that's one question from Rami asking about. You can mute yourself, sir. So one-tail is one direction. Two-tail is two direction. So one-tail is either good or bad, one direction. Two tails are both the good and bad at the same time. The effect, positive and negative at the same time. So if you have only negative, that's one tail. If you have only positive, that's one tail. If you have both the negative and positive, it's two tails test. So interview collection data, you will use the same questionnaire. I mean, it depends on the interview. Is it structured or unstructured or semi-structured? So if it's structured, you use the same. If it's semi-structured, you use 50% structured, and then you change some of the question. While if it's non-structured, there is no questionnaire. You go and interview people. So it depends on the structure of the interview. So it can be structured, can be semi-structured, can be unstructured. How many mean will equal mode and median in a normal distribution? I'm going to give you an example. So imagine you have 11, 10, 10, 10, and 9. Okay? So if you add 9 to 11, that's 20, and 10, 10, 10, that's 30, so 50. 50 divided by 5, that's 10. So the mean is 10. What is the most frequent value? Is 10, 10, 10, 3 times. So the mode is 10. And which one is the middle if you organize the number? So we have 9, then we have 10, we have 10, we have 10, and we have 10. If we put it from the small, what is the middle value? Is 10. So the 10 is the median, the 10 is the mode, and the 10 is the average. So that's a normal distribution. Okay. Now, if you do know, if you have, what is matching? What do you mean matching? I don't know what's the answer. There is no two blinded and one blinded. It's all level blinded. So the two blinded is the patient doesn't know and the researcher doesn't know. That's two level blindness. That's what's meant. One level of blind is the researcher does not know, but the patient knows. So two level of blind is the researcher doesn't know, subject doesn't know. I don't know what is you mean by the matching. What is matching? Matching is a word. So I don't know what is the question, so I can answer. Rami.
Matching between data and decreases confounder. It's one statistical analysis, but I don't understand. It's a way of decreasing confounder.
Oh, I see. So I think the better way is to decrease the heterogeneity. If you decrease the heterogeneity, you're decreasing the confounder. The more heterogeneity your examples, probably you mean that, then you have less confounders. So the more the data is inclusive, the more or the less your exclusive criteria, the more you have confounders. The more you have in your exclusion criteria, the less your confounders. I think that's what you mean by matching. I'm not used to the word, but I think you meant heterogeneity. It might be correct, and I'm not aware of it. Some people might use it.
Yes, that's what I mean. Thank you.
I'm trying to give example, Dr. Muhammad. It is difficult, I know, but you need to practice. You need to review, and then you need to practice. Now the
Hello, Dr.
practice
Yahya.
methodology, we need one by one. So we need a mentorship. We cannot do a practice because to do a methodology, you need to start from the beginning, from generating the question to testing, to reading, to and so on. And then, so you need a mentorship rather than a practice. So I give you a topic and then we'll do it one by one. You write, I review, and so on. So you need a mentorship program, not a practice. Practice is what I show you, but a mentorship program, I mean like a student-teacher relationship to write your own study, and you need to practice. I know it's very difficult. Without practice is not easy, but at least you are aware by 20% of the content. Yes, mom, you want to ask a question.
Yeah, I'm Dr. Yusra. I want to ask if I want to do a study, let's say, to study a pattern of disease from March up to June, let's say, and now we are on May. Is this a cross-sectional study?
From March to June?
March, yeah, to June, and we are now on May. Is it cross-sectional?
No, this is not.
Or could be cohorts.
This is longitudinal. This is a combination of before May, you're doing retrospective, and after May, you're doing prospective. So it's a combination.
Exactly.
Retrospective and prospective. It's a combination of recall and monitoring. It's a weird way of doing a study. It is methodologically incorrect, but it's possible.
I mean, if I want to study something during this pandemic, let's say, pattern of disease during this COVID-19 pandemic, which started on March.
Yeah, you either to start from now
and go forward.
Yeah, or you start from like December till now. So you can do that. You can do the other one, but it would be very difficult to test it because they have two types of data. You have a recall data and you have monitoring data.
Yeah. Okay, I see. Thank you.
But remember about your practicalities, not only the possibilities.
Yeah, thank you.
Yes, most welcome. Any more questions?
Hi, hello, Dr. Here. Can I ask you one more question? Hello.
Yes, please go ahead.
You were mentioning about systemic reviews.
Yes.
So you were telling that systemic reviews are basically qualitative studies. So
it's not quality. It is both, but it's mostly qualitative study. Yes, but it's not qualitative because you're testing the result. So, for example, if you have a study A and B, and study A said the average is 10, and study B said the average is 11, you're comparing both averages. While in meta-analysis, you don't take the average, you take the raw data and you put, and then combine it both and get your average, your own average. So that's a meta-analysis. This is a systemic review. Yeah, go ahead.
So basically, the difference between both is one takes the raw data from the start of the studies, start of different studies.
Correct.
That's
like
meta-analysis, and the other one is takes the results and compare the results. So when we compare the results, basically it is it also deals with the numbers. Then how can it be qualitative?
That's what I've told you. It's both qualitative and quantitative.
Okay.
So you can use the average and use them again, or you just can compare them. Okay. When you take the average and use them, remember it's quantitative if you can test. If you can do a test. So, for example, in Cochrane review, we do a test. We do mainly a relative risk and absolute risk. If you've seen a Cochrane review, so we talk. I have done 2 Cochrane reviews. If you search my name, and then you take the raw materials, you call the people if they agree, and then they put the data together and analyze it again. You run different analysis. It's different from study A, different from study B. It's become like the problem with meta-analysis is the heterogeneity, because when you combine both studies, they become more bigger sample size and become more variable.
Okay, got it. Thank you.
Any more questions? Well, I have to finish here. Thank you very much for listening. and I hope that you attend next session. Have a good day and Ramadan Kareem. Assalamu alaikum.
Wa alaikum salam.